Hi, I'm Meta Spencer. Do you think you need to know more about trees? Well, I've been looking at trees quite a bit, and I just love trees, and I love what they do for us, but I think we need to know more about them. So today we're going to find out, I think, more about transpiration, most likely, than anything else, because trees do very good things with water. And I am very interested in climate, and I expect you are too. And my friend Robbie Tulip in Australia is very interested in climate and spends all his time trying to fix the world's climate. But he has set me up today for a conversation about something that I haven't sufficiently studied, and that is how forestry and plants can help cool the planet. So today I get to speak with Rob Laet. I'm sure I'm still not pronouncing his name correctly, but be patient with me. I'll learn eventually, Rob. Rob is in Brazil, and I think he's going to go to Colombia later today. And he's obviously moving around the world trying to persuade people to pay more attention to the way plants can help us. So hello, Rob. It's good to meet you.
Meta, it's wonderful and it's a delight to meet you. And hello, Robbie. We have been in touch. We're basically on the same team for a while now.
Wonderful.
That's right, yes.
Well, I have a lot of questions that I've been carrying around. I didn't find the right person to ask until now. But I think before I start questioning you, you can give me your pitch, because I see that you're the co-author of a book. I can't remember the title. Tell us the title of your book and give us a little summary of your main argument.
Okay, yes. Well, the book is called Cooling the Climate. And the subtitle is that we can actually do that technically within 20 years, which sounds unbelievable. And I think it's still possible. But before we go into the climate, let me just take 1 minute to give the larger perspective. So I just turned 70, but since I was 16, when I read Limits to Growth, it was clear to me that the way humanity was operating on this planet was going to get us into big trouble. And a lot of people know the graphs that were signed in that book, that basically in this decennium would see a large drop-off of economic activity, population, resources, etc. So while I had a wonderful, adventurous life, I roamed the planet for decades on a shoestring, quite often sleeping on people's couches. And I know my planet pretty well. I also had this chip on my shoulder that I knew that there was this looming crisis, and we're in the middle of it now. And it's a poly crisis. Climate, of course, is the poster child of that poly crisis. But it's a poly crisis in almost all kinds of ways, from spiritual to economic to psychological to biological, etc. So the perspective is bigger than just cooling the climate. But I'll zoom in now to the climate and how I got there. That was after I sold my adventure travel company in 2007, I was able to full-time focus on solutions to climate change. And I gathered a lot of information, but slowly I found out that there was a big chunk missing in the IPCC models, because it's all about greenhouse gases. Now, don't get me wrong, greenhouse gases do heat up the planet. I'm not a denialist. So it's a blanket that is getting thicker, which gets us hotter. But there's another process which is basically absent from their models, which is the air conditioner. Active air conditioning is done by the world's ecosystems, especially the tropical ecosystems, which have evolved over the last 100 million years or so through the process of evapotranspiration, transpiring water through their leaves, cooling their area locally. And also, and maybe we can go into it a little bit later, also the ocean biology that helps, especially in forming clouds. And our activity, our economic activity with the 8 billion people of us, basically has been deteriorating those conditions. First of all, we have removed an area the size of China in forests since we started measuring the CO2 uptick. And a large part of that actually has been, since World War II, have been the tropical rainforests, which have been largely removed to feed the fast exploding population. And the point is, not all forests are equal. The tropical rainforests cool a hell of a lot more than, for instance, the boreal forests, which are the largest forest, in fact, in northern Canada, Alaska, and Siberia, and the Scandinavian countries. They also cool, but they only do that for the summer months when photosynthesis is happening, and they're dormant during the winters. While the tropicals do that all the time, and also they're specialized in cooling because at the equator, about 4 times as much sunlight comes in as compared to the polar regions. So naturally, the evolution of plant life there has been to produce this cooling and rehydrating effects through this water cycle. So if you look at the impact, we think, and we're still all calculating and we're fighting amongst each other, but we think that roughly half of the warming up of the planet that we see right now, which is basically 100% attributed to CO2 and other greenhouse gases, is actually caused by the degradation of the cooling capacity of ecosystems, and especially, again, tropical rainforests and ocean. There's several things that have caused this heating up. It would take a little bit more time, and maybe we can go deeper into it, but let's first look at cloud cover. If you reduce low cloud cover on this planet by 1%, you roughly get an increase of temperature of anywhere between 0.2 to 0.5 degrees centigrade. And cloud level has gone down. And I'm sure Robbie knows a lot about that, so maybe he wants to weigh in, but we'll see. So those clouds are produced by ecosystems. Basically, let's start again with on land with the tropical rainforests. So as soon as sunlight hits the leaves of the forests in the morning, a process called, we all know, photosynthesis, which we all learned at school, is happening. But the large omission that's not told at school is that it's not only producing oxygen while absorbing CO2 and making that into sugars. It also, for every molecule of sugar that is made, a couple of hundreds of molecules of water are evaporated through the stomata of the leaves. And that's an active cooling process. We all know that trees cool, but we think actually that it maybe is because of the shade that they give. And of course that cools too. But there's actually active cooling by taking this water out of the roof, pushing it to the leaves, and then pushing it out and make it into vapor. Now, we all know how much energy goes into boiling a kettle of water to put a cup of tea on. That energy is actually in those molecules that go from liquid water to vapor, which is an incredible amount. And that's actively taking energy that has been just coming in from the sun and absorbing it in this change of water from liquid to vapor. And then water vapor is lighter than air, so it whirls up. So the first phase is the active taking energy from the forest floor and putting it up in the atmosphere. Now, the engineering of Mother Earth is amazing, because what actually happens is that water vapor is also a greenhouse gas. So it would actually heat up the planet, but there's a second production of forests and all ecosystems, by the way, and that's the production of bioaerosols, which are small particles. Some are actually bacteria, but also other particles and terpenes, chemical substances. And they move up at the same time that there is this evapotranspiration. And those little particles, they allow water to recondense fast. So on a really hot day, when a tropical forest is really working hard, water vapor only stays in the air maybe 10 minutes. Then it has gone up to low cloud level area, and there it condenses around these bioaerosols. And a couple of things happen at this time. First of all, it's not a greenhouse gas anymore. Secondly, it forms clouds, which is an umbrella, which keeps light out. And third, there's actually more things happening, but let me just not make it too complex. But anyway, the third thing that is happening is that the energy that is absorbed at the forest floor, at the moment that the water vapor goes back into liquid, is getting emitted, but now higher up in the atmosphere. So now, go ahead.
You lost me a little bit. Okay, I'm glad you started with the business about water vapor being a greenhouse gas, because that was the first thing I was going to ask you later, because I'd heard that water is a greenhouse gas, but now you've explained it to me that it doesn't stay a greenhouse gas. It forms droplets around.
Exactly.
One of the things is, Meta, that when water is in gas form as water vapor, it heats the earth, but when it's in liquid form, it cools the earth. And forests have a really key role in converting water from gas to liquid, and preventing the release of gas. So it's such an interesting topic to delve into the water cycle and its relationship to forests and plants.
But now I'm thinking of, I've spent a lot of time with Stephen Salter back in the day when he was promoting marine cloud brightening with us, and I know that it sounds like what you're describing is related to what happens with marine cloud brightening, where they put salt molecules in the atmosphere, and that, I guess, is an aerosol, right? Particles of salt. And then you spray the salt up, and then the water evaporates from the salt, but leaving the little particle, which then water coalesces again and makes a very small particle that then becomes a cloud and can reflect light or create albedo. Is that it? Are you describing, when you talk about the terpenes and all of these things from the plant, is the process the same, or are we talking about two different things? The salt aerosol versus the little molecules that are excreted by the plant.
Yeah, it's basically the same process. The only difference. So I'm a guy, and I operate from the intelligence of evolution, and the crude possibilities of humans to actually do this process are there. So Salter's experiments I'm aware of and actually work. There's no doubt about it. At the same time, the bioaerosols are a mix of different particles and chemical substances, in some cases bacteria, that together actually are probably much more effective. And that has been evolved again over about 100 million years or so, when the so-called angiosperm or flowering trees have evolved that have increased evapotranspiration by a factor of 4. So that process is the same, but again, it's a crude mechanical way humans do it, and far less intelligent than what has been evolved in forests, and especially in tropical rainforests.
It's really interesting to get this comparison between trees as a source of aerosol and marine cloud brightening. The big problem with marine cloud brightening is there's been a lot of computer modeling about how it would work, but nobody's actually been able to make the aerosols in a cheap way in order to actually demonstrate it in the field. And so we've got trees which have evolved to emit these biogenic aerosols, and similarly with seaweed emitting the tang of the sea salt air known as dimethyl sulfide. And the sulfur in that is just a really strong cooling chemical. It makes clouds and it cools down the local environment. And we've just allowed those kelp forests to get destroyed by heat and other factors. And Rob's been telling us about how the terrestrial forests have also been destroyed, and just how dangerous that is for the stability of our planetary future climate.
Mm-hmm.
Yeah, absolutely.
The marine cloud brightening technology, if you will, only is practiced over the ocean. It's not, they don't do it over land. Now, are the chemicals that are produced by seaweed and phytoplankton the same as the chemicals being produced by trees?
No, I don't think so. I think DMS, as Robbie told, is the main substance, together with actually small salt particles from wave breaking that do the cloud forming over the oceans. By the way, there's something I really like to mention this, because it's sort of triggers at least my imagination. Healthy coral reefs actually also give off DMS, and on a hot day, a healthy coral reef actually forms cloud and actually even makes it rain over itself. So the Great Barrier Reef has cloud forming and rain forming over itself to cool itself if it functions right. And the most important part is the DMS that is emitted by the corals. So,
okay. But corals are animal, not plant. And
they're a combination of plant and animal.
Yes. Yeah.
Oh, okay. They are. Okay.
So the animal brings algae into it, and the issue around coral bleaching is that when the water gets too hot, the animal expels the plant that is growing within it, and that then causes the coral to bleach and die. And we're now at the point 1.5 degrees of warming, where the scientists estimate we're reaching the coral reef tipping point. So we can expect a lot more coral bleaching. And then with dead corals, we don't get, as Rob's saying, the local rain caused by the corals, and a whole collapse of biodiversity of coral reefs as a really key part of the planetary ecosystem. So really quite a serious problem. But we're mainly focusing on terrestrial forests. Do you mind, Meta, if I just respond to some of Rob's initial comments?
Yeah.
Please.
I want to mention this experiment that's been going on in the Great Barrier Reef with marine cloud brightening, which I think has not proved to be. I don't know what the problem is. I think it has something to do with
It's cost. The problem is that the technology that they have developed to create the really tiny submicron particles of salt is just uses such a lot of energy that it can't be scaled up. And so what's needed for marine cloud brightening to work is an investment on the scale of the COVID vaccines. Like I'm sure it can be solved with that sort of investment, but it still has not been solved how to make the salt aerosol particles in an economical way. Whereas trees, you can do it. Trees are great value for money.
Okay, but now when they are trying to do marine cloud brightening there, are they trying to replicate the natural phenomenon where the the coral produces this DMS themselves, or
No,
are they doing
it's quite
something
different
different?
because the issue is that natural waves make salt particles that are quite big, and it's called the Toomey effect. That the smaller the particle is, the overall the more reflective it is. So if you've got a kilogram of tiny particles, that will reflect a lot more sunlight than a kilogram of big particles. And so the challenge is how to optimize the particle size in order to do the reflection. But Meta, I think marine cloud brightening is another topic, and I think that there's a whole lot that we can focus on with Rob on the trees question, because like to me it's just been really fascinating to focus in on the role of trees, because like I had always assumed, as Rob said, that the reason we have trees in our street is for shade, and that's why they make the urban streets cooler. But then Rob explained to me this really key distinction between what's called sensible heat and latent heat, and those are scientific terms that I was not really very familiar with. But basically, what it means is that when the sun hits the sidewalk, that it heats up the air, and that's we can sense it, and so that's called sensible. But when the sun hits a tree, it causes the water that's in the roots of the tree to evaporate. And as Rob was explaining, like boiling a kettle, when you evaporate water, so much of the energy that's in the sunlight goes into that phase shift from liquid to gas, that instead of producing heat that we can feel, it produces water vapor, and then that water vapor, it increases the humidity, but then that humidity spreads around, it goes up and makes clouds. A lot of it, when it goes up to make clouds, radiates out to space. So there's this really important latent heat cooling function of plant matter.
Let me question you on that thing, because I mean, I've talked to a lot of foresters, and they are not talking the way Rob is, and trying to see to imagine the difference between the various ways of seeing the effect of forestry or a force on the environment. Is the main point that you're making that differentiates your point of view from foresters, is your main point that there's energy involved in converting from one phase to the other, from
liquid to gas?
Liquid to gas. Is that where you would differentiate your point of view from the predictions of the calculations that foresters usually bring to this conversation?
Absolutely, yes. And actually, there's a third change of phase that, as you know, from ice to liquid to water. And in every phase change, there's an enormous amount of energy changing hands, if you like. And it's the most important energy transportation vehicle of the planet. For instance, if you heat up ice of 0 degrees, and to change it into liquid is exactly the same amount of energy that is needed to have liquid water of 0 degrees heat up to 80 degrees centigrade. So there's so much energy absorbed or emitted in this phase change of water, and nature has been using that in so many ways to basically regulate temperature and climate.
But where Rob differs, I think, from a lot of the established climate policy is that, for example, the IPCC sees the main value of forests as a store of carbon. That is, as removing the carbon dioxide from the atmosphere and storing it long term. But Rob's pointing out that there's this whole other dimension of the value of forests in the evapotranspiration process, that there's a physical cooling of the whole atmosphere, the local climate around the forest, and that climate models haven't sufficiently taken that into account. That's your point, isn't it, Rob?
Well,
absolutely.
Excuse me, but I know that a lot of foresters do talk a lot about evapotranspiration. So it's not that they're ignorant about that. I've just not heard them talking about any change in the amount of energy being expended or not in the phase change. That I'm wondering if that is where you would depart from traditional or mainstream forestry.
It's very, very well known that, it's pretty basic physics what Rob is talking about, but it's I think it's a question of the politics around climate models and how the models that the climate science community use to create policy priorities really need a bit more thought, and so the potential of and so there's broad support within the climate action movement for reforestation, but I think that the general public doesn't have a good enough understanding of the reasons why that is so important.
Well, there's an additional problem. I mean, it's very easy to measure the effect of or the amount of CO2 in the air, and it's roughly globally the same. While the whole water cooling effect is shape-shifting all the time, so you can't put it in a spreadsheet. It's very difficult to model, and if you can't model it, it doesn't exist. In fact, there's a
that's not literally true, Rob. It still exists, but that's the assumption in the models, that if you can't model it, it doesn't exist. Yes,
exactly. Yeah, of course it exists, but it's being forgotten. I think the story is from Walter Jehne, and I'm not sure if it's true, but the rumor goes that when Jimmy Carter first heard about climate change, and they told him about the effects of CO2 as a warming vehicle, and the other one, the water cooling vehicle, but they told him that the water cooling was far more difficult to model. So then he said, well, just give me the facts on CO2 then. And that there was a sort of a split at that moment, that people have been focusing just on the blanket, the warming effect, and not on the active air conditioner, which is the water cycle. I'm not sure if it's true, but it's a nice anecdote. But we need a two-legged climate policy. One is getting out of greenhouse gases. We all know that there's no doubt about it. But the other one is to regenerate our damaged planet's capacity for cooling, with the two largest one is oceans and tropical rainforests.
See, my concern, Rob...
I'm having trouble squaring what you're saying with what I hear from most foresters, which they are sort of not very optimistic about reforestation as an effective climate cooling methodology, because I think they would say it just takes too long to regrow all these forests. It's a big operation, and that you probably it's going to take 40 or 50 years to get a good tree, and you need a whole bunch of them. So this
Well,
And
need
this
we
is where
need reforestation, and everybody likes trees. Nobody's against it, but I don't hear many people saying that this is the first, order of business.
no, it's. I really have to. I really have to say something against it. There's actually an article that came out last week, and they had been monitoring pieces of tropical rainforest in Ecuador, and how they bounced back after being left alone. And after 30 years, basically, most of the functions that were in the old growth forest actually also were now happening in the new growth forest. And none of the work was done by humans. I think humans are completely overestimating. We're very good at destroying the planet. I'm not saying something against that. But again, with this crude methodology of marine cloud brightening, yes, it's possible, but we're very clumsy compared to the technology that nature applies. And the real bounce back of the tropical rainforest in that area was basically done by birds, by mammals, by insects who did the hard work. Mm-hmm. And so the idea that we should be planting trees is almost, I'm not saying 100%, but 90% is unnecessary and inefficient. But we can create the conditions for nature to actually grow its own trees. I always joke, I've never seen a tree putting a seed in a plastic bag and wait for 4 months before they can put it in the ground. Trees are seeded directly by nature, and we can increase. And so, I mean, I'm living in a small valley in the tropical rainforest, which I'm reforesting, and I've seen the differences between letting the forest do it itself, helping it, and I did one part, I plowed it and I planted all the trees. I can tell you that the assisted regeneration, so helping nature to boost the growth, is by far the best method, and there's very little tree planting in the whole process.
See, part of the concern is, yes, we have the blanket, which is the greenhouse gases. We have the air conditioners, which is the vegetation. But then we also have the mirror, which is planetary reflectivity, albedo. And that mirror has been getting quite dusty in the last couple of decades. And the problem, Rob, that I have with the strategy that you're outlining is, over the medium term, it's excellent, but in the short term, there are such major barriers to reforestation, whether artificial or natural. And so I'd mention drought and pests and fire.
Oh, sure.
And agriculture, deforestation. And so the culture shift that is required to achieve a restoration of the planet's forests requires a change of thinking in our societies, which is, as Meta was saying, like, it's not just that trees are slow to grow, but that forests are under assault from climate change and other factors. And so forming an integrated approach, this is why, my sense is that restoring albedo is the first requirement in order to create the conditions that will be conducive for forest growth.
Why do we have to choose? I'm always annoyed because
it's about sequencing matter. Like, the thing is, we currently have an official policy which says that the first thing to do is to reduce emissions, and that things like restoring forests and restoring albedo can be thought about later. And I'm saying that that sequencing is impractical and needs to be reversed. That we need to focus first on albedo, because albedo is it's a crisis that can be reversed, whereas the ability to reverse the carbon crisis is so much more difficult. Like the powers that be that want to continue emitting fossil fuels are completely overwhelming the efforts of scientists to and others to stop that.
Okay, I'm not going to argue with that. I think clearly it's a mistake to focus entirely on reducing emissions of greenhouse gas. But as far as the other things are concerned, why not? Why is it a sequencing problem? Why is there any need to sequence? We should do everything we've got. Throw whatever you've got into the mix.
Exactly. We are completely on the same page, Meta. The first thing is we have to get the world to wake up that it's not just about greenhouse gases, because otherwise we can forget that the money should be thrown at it. Robbie, please go on with the marine brightening techniques that you guys are doing. I'm in that group as a fly on the wall, as you know. Every now and then I say, but don't forget nature. That's my only role. But I think we should do all of these things. I'm right now. We should be pushing them all.
We should be pushing them all forward simultaneously. But we can expect results quicker from albedo restoration than from albedo restoration can cool the climate much faster than emission reduction or carbon removal or even reforestation.
Well, but don't underestimate. I think there's a lot of underestimation. The whole problem is basically that we're so anthropocentric. We are overestimating what we can actually do compared to nature. I'll give you an example. You probably heard of Just Dig It. It's an organization that does a lot of restoration work in mainly East Africa. And what they one of the things that they do is basically make half circles in dried out areas, so that when the water falls down, it stays in those little puddles so that it can percolate in. Now, there's enough seeds in there, so then within 4 months, you see that there is vegetation where there wasn't. And I talked to the person who led a satellite observation of these areas. And within 4 months, there was half a degree permanent cooling on these puddles locally. Okay, that doesn't cool the climate globally, but in the end, I quite often joke, if we can get the heat up to the outer atmosphere, that's the outer atmosphere's problem right now. Let's cool it down here. And so this is 4 months by making these bunds, these half circles, and the humidity went up, which is basically the start of a cycle of getting more vegetation. So don't dismiss the effects. I know in my own forest, in my own valley, springs came back within 5 years after we planted some trees around them that before was pasture. Don't dismiss nature as a slow process. It's especially in the tropics, it's underestimated by people.
Yeah, it's just that it's so tough. Like your experience in Brazil, you would have seen all of the deforestation activity. A lot of illegal deforestation and burning of forests. It's really quite. There's people worry that the Amazon is at risk of switching to savanna. That's
even deserts. Yeah. Absolutely. So that's why I have a project called Arara, and the idea is, we have a technology platform and a plan in place, which still needs finance because it's very difficult to get our stuff financed. But anyway, basically it says pay everybody in the forest to protect and regenerate their own part of the forest. And there's about 1.5 million families that live in the forest, not in cities in the area, but and if they would all get paid and rewarded for doing their part, we could probably have it bounced back. So and it's absolutely necessary, because as the Amazon goes, basically the macro effects on the global climate are enormous in terms of temperature, droughts, food baskets that will go to hell. Basically, it's show over.
It's identified as a tipping point. Yes.
Yes.
Let me ask a different kind of question. I have gotten interest a couple or 3 years ago, was very interested in how the effect of different trees will differ. Certain trees are more cooling than others. In fact, some trees actually apparently warm the environment, maybe the soil. I was in touch with, in fact, I interviewed a guy in UK who was comparing different species in terms of their effect. There'd be a plot of land with, solid growth of one plant. I've forgotten which trees he was comparing, but some of them actually warmed the soil. And there's another book, which I can't remember the title of, but a man went all around the Arctic, every country in the Arctic, and looked at the growth of trees. And it's a bad thing to have trees expanding, but forests are growing where they don't belong, because the effect of trees in the Arctic is just to have a warming effect. That's my understanding from him.
Yeah, Rob.
And
Rob
as
made
well
that.
from these guys in Siberia, the I can't think of the father's name, but Sergei and Nikin.
Oh, to
Rob
put back
made
the
that point.
megafauna. Yeah.
Rob was talking about the contrast between tropical forests and boreal forests. Of course, boreal means the ones that are in high latitudes near the Arctic, and the issue is that there's a big difference between the evergreen conifer forests and the deciduous forests. So when the deciduous forests lose their leaves in the winter, then the sun hits the snow underneath them and reflects back. But because the pine forests keep their leaves through the winter, they're dark and they absorb that heat, and so pine forests tend to be warmer than deciduous forests.
I'd heard that.
Yes. Yes,
but
it's
the
true.
problem is, in all of these countries in the north, they're feeling the effect and regard it as a big problem that trees are going where they don't belong, and things. It's warming the soil. Even caribou herds, things fall through the ice and cut their legs because the ice is sharp, and they can't. They're worried about even being able to continue herding caribou or reindeer or whatever they're called. So the growth of you don't want trees expanding in the far north, but I guess you certainly do in the tropics, right?
Well, yes, my focus is on the tropics for the very simple reason that most sunlight comes in at the planet, and what we need to do is cool the planet. I mean, if you put an umbrella over the North Pole, which, by the way, is needed because of the Arctic amplification, but if you put it over the North Pole, the effect is simply much lower than you put a similar umbrella over the equator. The effect is 4 times bigger around the equator. That's why what I'm saying is that a large part of the heating up of since World War II attributed to CO2 is actually should be attributed to the destruction of tropical rainforests. And that distinction is not made in mainstream climate science.
I wanted to get back, Rob, to your comment in your introductory remarks about how the climate crisis or the polycrisis is also a spiritual crisis. And one of the themes that you've raised in some of your writing is James Lovelock's Gaia theory. And one of the common misconceptions about the Gaia theory is that it's a sort of mystical mythology, but you've talked about the concept of homeostasis as a way of understanding the Gaia theory. Is that something that you'd be able to explain to us a bit more?
Mm-hmm.
Well, yes, but I will tell it to you in the most radical sense. I mean, we have consciousness. You, us three in this room, we have consciousness and self-consciousness. We have no clue exactly how that works. We know it's in its current form, it doesn't work when we're dead. But otherwise, we can't really put our finger on how this is produced and what it actually is. And this is exactly how we see the whole world from this consciousness. Now, imagine that we also have found out the last 20 years or so that we are actually made up of trillions parts that are basically alive cells with virus particles in it that work sort of together. We all know about our gut flora, etc. Maybe you should see a human more like an ecosystem of millions or trillions of individual living things that together produce our living bodies, our metabolism, our homeostasis, and our consciousness. Now, if
Can you explain the concept of homeostasis?
Homeostasis is basically that the total biological processes of an entity, let's say a human or a deer or a plant, basically produces sufficient balance in temperature, humidity, etc., for that life form to be able to survive and thrive and be stable. Yes, and all life basically, all life has possibilities to stabilize its surroundings with these processes and internally. So that's homeostasis, and that works for all living beings in some form or other. Now, if you transmit,
if you listen to Michael Levin, I don't want to interrupt this, but he is the guy at Tufts University who has been developing biological models of how all cells contain minds. We have purposes that are built in, and they can be changed. But
I think the interesting thing is how the homeostasis that operates at the individual organism level also appears to operate at the planetary level, and that's
exactly
James Lovelock's great insight with the Gaia theory.
Yes, and it's not just his insight. I mean, it's an insight from a Western guy, but basically, a lot of the indigenous cosmologies basically say Mother Earth is alive. And Mother Earth is a person and is an intelligence and is a living being. So maybe we could vision ourselves as part of a huge living being that is producing the conditions for life to thrive. And we are just part of it. And so it's a sort of a Copernican revolution that we need, where we finally humbly find the real place in the whole thing, instead of thinking that we are the center of the universe as humans. So you need a shift and understanding in this perspective that we are part of a large living being that is actually intelligent and regulates its own situation intelligently. That's basically my interpretation of the Gaia theory.
And so seeing global warming, comparing that to a person having a fever, like, you sometimes hear people say, oh, what difference does 1 degree make? And if you've got a fever, then 1 or 2 degrees can be the difference between being fine and being confined to bed. So thinking of the planet as a person is a really interesting way approaching it. And it doesn't need to be a sort of magical theory, because it's something that's a very scientific approach to understanding the planet as a whole, as a unitary system.
Yeah, absolutely.
You can make it a mystical thing if you want to think about it that way. But the team at Tufts is working very much in insisting that every assertion that they come up with has to be grounded in experimentation and hard evidence. So they're looking at the way coordination takes place among different local minds. So if we have millions of cells that all have a little bit of a mind, in the sense that they have something they're supposed to do, and if they can't do it, they'll find another way to get there. If you block one way of their achieving their built-in goal, they will find a way around it and try to find a way around it, and sometimes they succeed. Anyway, that coordination and how flocks of bees and birds and things, how they coordinate. And it leads up to the question of how maybe society is coordinated in using some similar thing. I think Levin's main argument is that it's bioelectricity that is very effective at the cellular level. God knows what it is at this planetary level. Anyway, I should stop talking about that guy I spend all my free time watching his videos.
But Meta, if you'd like me to transport that image to the global level, actually, okay, we as a species, we've been making what we call sort of history for the last 10,000 years or so, and which of course is a very short moment in the life of the planet. But in that period, we actually have developed, apart from ruining a lot of nature, we have actually developed what I would call sensory perception of the planet. So satellites that can look outside, but also all kinds of instruments that can look inside. And right now, we're at the level that if Trump has a bad night, everybody wakes up nervous. Now, and that's through the neural system we call the internet, that has been that is basically synchronizing our collective thinking. And and that so if we look from a kind perspective, maybe what is happening is that this intelligent planet is slowly becoming self-conscious of what is happening on a global level. Mm-hmm. And it's a little bit difficult to wrap your head around it, but on the other hand, we might be just part of a huge jump in evolution right now, which is similar to if you go from single cell to multiple cell, or you go from life going over the threshold from ocean to land. We might be in something much bigger than we realize, and that could be this planetary self-consciousness being triggered by the combination of this neural network, and at the same time the push of us destroying all its systems for homeostasis.
Yeah. So what's if you compare the planet to a person, when a person gets a fever, the body naturally generates antibodies and white blood cells to fight the fever off. And so it raises the question of what are the planetary antibodies that are being brought into existence to fight off the fever of global warming and of the polycrisis. And part of it is understanding humanity as like the question of, can we actually use our brains in order to shift our planetary system to a sustainable path?
Well, I'm not counting on my brain to be able to do that, but I think you guys were going to do it for me, and we've run out of time. This is such an exciting thing to be thinking about. I just love it. So I did not expect to go here in this conversation, but it's certainly worthwhile. Yeah.
Can we invite Rob to just offer some final comments?
Of course.
Well, yeah, no, I'd love that we came here, and I'd love us to actually have another conversation, maybe around this whole perspective of this planetary involvement, and actually, Robbie, both you and I, we're very pessimistic that we as a species will get out of this crisis with most of us alive. It's very unlikely, but it's not impossible. And I think we have to focus more and more on understanding this global vision and being part of a living planet, because it makes our self-interest suddenly a planetary interest, and vice versa.
Wonderful.
Which is such a paradigm shift, and it's something that, like you say, pessimistic, and looking at the idiocy of a lot of politics, I can understand why people are pessimistic, but I'm actually quite optimistic that we're on the brink of quite a significant change in thinking, which will enable a change in policy and a return to planetary health.
That's a good way to end. I can't think of a better way. An upbeat ending. Thank you, guys. It's been wonderful.
Thank you for the invite.
Yeah,
Thank
I
you.
enjoyed it very much.
So nice to see you, Rob, and thank you, Meta. Bye-bye.
Okay, bye.